Hello everyone, welcome to today's video. So in this today's video we shall actually look at a problem from the concepts of series, mean the progression, and a bit of matrices and determinants. This is a pure logical problem, provided you actually know the concept. So your concept will give you the path for the logical thinking. Like you will be getting a hint of like you need to think in a logical way to actually solve this problem. So the question is, if the number of possible real values of x for which x, box x and fraction part of x will be in HP, that is harmonic progression is k, and a power k plus b power k plus c power k is less than z, provided a, b, c are real numbers and at least one of a, b, c as a magnitude between 0 and 1. So this is a very key point to note. Then find the values of z. Also cx plus also there are three equations given: x is equal to cy plus bz, y is equal to az plus cx, z is equal to bx plus ay are system of equations which have a non-zero solution. So this is another key point. So there are two key points given: one of abc as magnitude between 0 and 1, and the other three equations are like have non-zero solution. So we shall actually find the value of k first and then we can proceed further. So given x, box x and fraction part of x, these three are in HP. So the basic condition, 2 by box of x is equal to 1 by x plus 1 by fraction part of x. This is the basic condition. Now let us assume x is some like n plus f, where n is the natural number and f is the decimal part. Fine. So we can express x in this way, whatever it may be. Like even if x is a pure integer, we can express this in this fashion, because f can be 0 if x is a pure integer. So it's not a natural number in the sense I'm not confining myself from 1 to infinity. I mean to say like integer. Fine. Integral part, more concise, like integral part. So this we can write this as 2 by, so box of x would be box of n plus f, that would be n itself, and integral part itself, and 1 by x in the sense 1 by n plus f, and plus 1 by fraction part of x, that is f. So that is 2 by n is equal to, so taking the LCM and solving it, n plus f, so this would be f plus n plus f. So that is, so cross multiplying, so twice of nf plus f square is equal to n square, and there are two f's and into multiplied by n, so that is 2nf, and we can actually see some terms getting cancelled. 2nf plus 2f square is equal to n square plus 2nf. So 2nf and 2nf gets cancelled, so we'll be remained with n square is equal to 2f square. Fine. So that is f is actually equal to n by root 2. Fine, n by root 2. We can even get into this right conclusion right now, but I just wanted to make sure all of you understand what's actually happening here. So f is equal to n by root 2, and we know the range of f is basically 0 less than f less than 1, right? So, and also I've missed another thing, that is minus n by root 2. So that is 0 less than or equal to n by root 2 less than or less than 1, and the other case would be 0 less than or equal to minus n by root 2 less than 1. So that is 0 less than or equal to n less than root 2, and in this case we would get n we'd be getting minus 2 less than minus 2 greater than n less than or equal to 0. I hope it is clear for you people. Like we have just interchanged that signs, inequality gets reversed because we have a negative here. So if this is the case, what could be the values of n? What could be the values of n? N could be 0, 1 because integral parts, and less than root 2, that is 1.4 something. So the possible values of n are 0 and 1, and in this case the possible values of n would be minus 1, 0. So in total the possible values of n are 0, 1 and minus 1. Okay, so 3 values. And now what would be the values of f for each of them? So f in this case would be 0 by root 2, like it would be the same thing, 0 itself. And when we actually plug in 1 by root 2 and 1 minus 1 minus like when you plug in the value of n is equal to 1, we would be getting 1 by root 2, and the other case we would be getting minus 1 by root 2. Actually, so when we actually have the values of x, what is x? X is equal to n plus f. So when n is equal to 1, your f would be 1 plus root 2 and the other part would be 1 minus 1 by root. Yeah, there is a small mistake here. The reason is f cannot be negative here, fine. So, when we are actually having n to be minus 1, so we are actually considering this case. So, when n is equal to minus 1, we are actually considering this case. So, minus of minus 1, that is 1 by root 2 and the other case is 0. So, basically we will be having two values of f. So, two values of f in the sense it is a direct part. So, we will be having two values of x. So, x is equal to 1 plus 1, 1 by root 2 and the other part would be minus 1 plus 1 by root 2, minus 1 plus 1 by root 2. I hope you people actually understood what we have actually done here. So, we are having two values of x. So, basically the value of f will actually limit to the values of x itself, because f cannot be negative. So, we can actually take away the part which is negative. So, we are only confined to the positive values and there are two possible values here. So, value of x, number of values of x is 2 here. So, from here we can actually derive that k is actually equal to 2. So, k is actually equal to 2. Now, we need to find the maximum value of a square plus b square plus c square, in the sense like the limiting value in the upper bound. So, a square plus b square plus c square is less than z and we need to find the value of z, and I will just erase all this stuff. So, we will just write this that we have derived now. K is equal to 2 is what we have derived, fine. K is equal to 2 is what we have derived. And now, given three equations are given, let us write them. So, x minus cy minus bz is equal to 0 is first equation, first equation, and y minus az minus cx is equal to 0 is the second equation, z minus bx minus ay is equal to 0 is the third equation. So, these are homogeneous equations, and what can we say regarding homogeneous equations? That they have a trivial solution. So, they have a trivial solution in the sense 0 comma 0 comma 0, fine. So, you can even directly check that 0 comma 0 comma 0 satisfies it. So, it is a trivial solution and 0 comma 0 comma 0 satisfies it. But in the question it is clearly mentioned that we have a non-zero solution, fine, we have a non-zero solution. So, and also we need to remember the part like homogeneous equations can never be inconsistent, fine, can never be inconsistent. So, in that case either they have trivial solutions like that is 0 comma 0 comma 0, or the other case would be infinite solution. So, if it is a case of infinite solution, what is the difference? So, in trivial solution the delta will not be equal to 0, and in this infinite solution the delta would be equal to 0, that is it. So, we will become we have come to the conclusion that because it is a non-zero solution, so it cannot be a trivial solution. So, in that case it could be only a infinite solution. So, if it is an infinite solution, then delta would be equal to 0. So, we will find the determinant now. So, that is 1 minus c minus b and minus c 1 minus a, and the other part is minus b minus a 1 equal to 0, fine. And now, this is actually 1 of 1 minus a square plus c times minus c plus a, okay, there is a negative here, minus ab and minus b times ac plus b is equal to 0, fine. So, that is 1 minus a square and we have plus c minus c. So, that is minus c square and minus abc and minus abc minus b square equal to 0. So, that is 1 is equal to a square plus b square plus c square plus twice of abc, fine. This is the equation that we have got. Now, what can be the conclusion that we can derive? So, they have asked us to find the maximum value of a square plus b square plus c square plus 2 abc. So, and also there is one more important part, that is at least one of ABC has magnitude between 0 and 1. So, that means one of the magnitudes of ABC, like it is being confined to 1, like it is being confined between 0 and 1. So, let us assume that he is actually talking about A, like the question is actually mentioning about A. So, we will assume that it is about A and we shall proceed further, like in this fashion, like we will be having A terms at one side, A square plus 2 ABC, and the other parts we will just send to the other side, 1 square minus b square minus c square, because we are actually confining ourselves regarding A, because we know the range of A, that is between 0 and 1. because you have in the question it's clearly mentioned that one of them, at least one of them, will be in the range from 0 to 1. So let us assume it is a itself. Okay, so a square plus 2ab is equal to 1 minus b square minus c square. We know a formula, that is 1 minus x minus y plus xy can be expressed as 1 minus x into 1 minus y, isn't it? So you can even cross check 1 minus y minus x plus xy, right? So in the same fashion we have 1 minus b square minus c square. What if we had plus b square c square on both sides? So in that case it would be a square plus 2abc plus b square is equal to 1 minus b square minus c square plus b square c square. Fine. So in that case this would be 1 minus b square into 1 minus c square, and this is actually, so if we actually see this carefully, we have a square b okay, so this is b square c square. So I'm trying to add b square c square on both sides, right? Because I'm considering this as x, this as y, so xy would be b square c square, and we need to have plus here, yeah, according to this formula. So when we actually see this carefully, we have a square plus b square c square and 2abc. Fine, a and bc. So this is basically nothing but a plus bc whole square. Fine. So what can we derive with this? The conclusion that can be derived from this is a positive term, because a plus b c whole square, right? So it's a positive term. And for that to be positive, like your left hand side is positive, and for that to be like your right hand side to be positive, this must also be positive, and this must also be positive, or this must be negative and this must also be negative. So both of them need to be positive and both of them need to be negative. Now similar analogous forms like a plus bc whole square is equal to 1 minus b square into 1 minus c square. Let us now have the another similar analogous forms, like because it's a plus bc, we have 1 minus b square into 1 minus c square. What if it's b plus ac whole square? If that is the case, we'd be having 1 minus a square into 1 minus c square. What if it's c plus ab whole square? That would be 1 minus a square into 1 minus b square. So now as we have considered a to be positive, like a to be in between, like 0 and less than a less than 1. So as we have confined our a to be in between, so this would be positive, right? This is positive, and if this is positive, this must also be positive, because this is a positive term. So 1 minus c square must also be positive, and if 1 minus c square is positive, as this is positive, so this must also be positive. So what we have come to the conclusion is 1 minus a square should be greater than 0 as it is positive, 1 minus b square should be greater than 0 as it is positive, 1 minus c square should be greater than 0 as it is positive. So 1 is less than a square, 1 is less than b square, and 1 is greater than a square, 1 is greater than b square, and 1 is greater than c square. So that is a square plus b square plus c square will be less than 3. So the value of z is actually equal to 3. So z is actually equal to 3. So this is the point. So z is equal to 3. I hope you guys actually understood this. So it's a very logical question, like transforming this point, like this part into this part, is a very like this one, very logical thing. You actually need to confine yourself to one of the term, like a or b or c, and then proceed further, and also using this formula. So this formula, like you need to get this point catch, and the other stuff, like this is a very conceptual stuff. This is the conceptual stuff here. Like you need to understand why did we actually have the det to be 0 instead of having det not equal to 0, because it's in the case of homogeneous equations and it's a trivial solution. That is a possible thing. And what do you mean by trivial solution? It's a 0 vector. So that means 0 solution, but it's in the question it's clearly mentioned that it's a non-zero solution, so we must not go on to it. So that means we must not have our det to be non-zero. Instead we must have our det to be 0 for having infinite solutions, that is non-zero solution. So I hope you guys actually enjoyed this problem. So there are a lot of things we have discussed, and yeah, so this is a super duper problem. Like even though it looks easy, it is a combination of conceptual as well as logical. Yeah, so thank you for watching this video. Stay tuned.
Any more questions?